Dear student, today we are going to discuss one of the most important type of corrosion, that is soil corrosion. As all of us know that whatever construction we make, it must have a baseline, and that is, in many situations, it is soil only. And therefore, this kind of corrosion is very, very dangerous for any structure or metal buried in soil. Actually, this refers to a complex phenomena involving several variables. This includes the reaction with any specific element which may be available on soil. And therefore, soil-like environment may also be corrosive. And consequence of soil corrosion may lead to complete failure of the metallic structure. And therefore, to have a structure for long time persistence, design, construction, and complete understanding of corrosion potential of soil must be considered. Otherwise, if we make a structure without considering these points, it will not go for a long time, because there are several issues which may contribute to the corrosion potential of the soil, and we will discuss one by one. This is the contributes to the soil potential, corrosion potential of soil. There are so many parameters. Number one is, you know that aeration. I will discuss in detail. Number two will be pH. Number three will be your moisture and resistivity. And number four will be temperature. But out of all, there are three determining factors which determines the rate of soil corrosion. They are, that is, high electrical conductivity. Number two is high level of moisture content. And number three is high level of salt content and pH. These are three very important parameters which determines the rate of soil corrosion. Now let us discuss one by one. Let us start with aeration. Perhaps all of you understand what is aeration, flow of air. If we want to understand this phenomena, so first of all we have some idea about soil. Actually, soil may be basically of four types. Number one is sandy soil. Number two is loam type. Number three is clay. And number four is peat or muck. There are four types of soil, out of which the sandy soil is actually light, warm, and it is likely to be acidic in nature, and therefore it contains high proportion of sand and less amount of clay. as a result of which aeration is very free and flow in case of sandy soil. If it is loam, it is actually the mixture of three things. Number one is sandy soil, number two slit, S-L-I-T, and number three is clay. And slit is actually in between sandy and clay, and therefore it helps in mixing both of them. And third one is actually your clay type. It is mainly made of mineral particles with very low organic content. They are sticky in nature. Water drainage is very poor. These are the actually general feature. And number four is your peat or mud type. This is actually the most dominant organic soil, and it is produced in centuries by partial or undecomposed plant residue. All four types of sand are written here with their corrosion resistivity. If your yard is sandy, it will have excellent corrosion resistivity. If it is loam, it is good. If it is clay type, it will be fair. If it is peat or mud type, it will be very, very bad. And therefore, before making any construction, choice of soil is a most important point to be considered. If your land site where you are going to construct a building or an industry, and if the soil nature is sandy, the soil will have excellent corrosion resistivity, and the structure you are going to make, it will go for a long period of time. And from here you can easily understand it will be easy for you, easy for us to make or construct a building or industry over there and go for a long time. Now, what I was telling about aeration, and therefore, if your soil is sandy type, the particle size will be bigger, there will be free aeration, and it will increase, but facilitate high actually evaporation rate of water. As a result, rate of corrosion will go down. Number two is pH. As we all of us know that it is a very, very important parameters. Generally, pH value of soil varies from 2.5 to 10. But soil having pH 5 and below 5 will be acidic, and therefore in acidic situation rate of corrosion will be very high. Generally, the pH on and around 7 is desirable. Next one is your moisture and resistivity. This is very important parameters. We know that moisture plays a pivotal role in making an electrochemical cell. And therefore, if moisture content is very high, resistivity of soil will be very low. And therefore, we can tell that the relation between moisture and resistivity, they are actually inversely proportional. Your soil, if it is more rich in moisture content, it will have less resistivity towards corrosion. And therefore, we have to ensure that moisture content of the soil should be as minimum as possible. Next point is your temperature. As all of us know that temperature has an effect on soil resistivity and corrosion potential. If the temperature is nearing towards zero, resistivity will definitely increase. And if temperature continues to decrease further, there will be a drastic increase in soil resistivity with corresponding decrease in corrosion potential of the soil. It means lower will be the temperature, resistivity will be the higher, and corrosion potential will be minimum. These are all about your soil corrosion. Now we have to see, as we have discussed in one of my previous lecture, the total amount of revenue we are losing due to corrosion is huge. But if we analyze, we will see that a significant amount of revenue is lost due to soil corrosion, due to destruction of metal and steel product buried inside the soil. Now let us see how can we control it. As we have told you, complete control is never possible, but we can adopt. As also we know that whatever we build on soil surface, they will be susceptible to soil corrosion. But we can adopt three different measures. Number one is cathodic protection. Number two is sacrificial anode. And number three is coating. Actually, all these three things we'll be discussing in detail when we'll be talking about your corrosion control. Just I am giving some idea. Cathodic protection, this is an approach. As we know that during corrosion, oxidation takes place at anode, corrosion takes place at anode, cathode remain completely protected. And therefore, in this approach, somehow we make the product, but make the metallic structure to be protected cathodically. As a result, the entire metallic structure will remain protected. In sacrificial anode, this is very, very important. In this, what we do? Suppose there is a particular metal A. We want to protect it. In this situation, what we will do? We will actually connect B with the soil, and electrical potential, electrode potential of B is more than that of A. That is, B is more electropositive than that of A. In this situation, B will be your anode, A will be protected. That is, we are saving A at the cost of B, and that is why it is known as sacrificial anode. We are protecting A anode at the cost of B anode, and therefore B is known as sacrificial anode. Third one is coating. As all of us know that it is the most extensively used technique to control corrosion. These three measures we can adopt to control soil corrosion. This is all about soil corrosion. Please go through the video very carefully. If there is any doubt or any point, please get it noted. We'll try to clarify your doubts in the next lecture.